Let's jump right into this explainer. Have you ever stopped to wonder how streaming platforms know exactly who gets paid when you hit play on your favorite track? Well, the crazy reality is, a lot of times they actually don't. Today, we're unpacking a massive multi-million-dollar headache in the music industry, something they called the Metadata Miasma at the 2020 DDX Virtual Creator Credit Summit. And more importantly, we're going to connect that crisis with a truly fascinating technological fix, U.S. Patent 12,664,142, invented by Kyle McLean Smith. Here is what we are covering today. 1. The Metadata Miasma. 2. Capturing credits at the source. 3. Kyle Smith's patented solution. 4. An event-driven tree database. 5. Automating royalties and rights. And finally, 6. Exploring all possible paths. Section 1. The Metadata Miasma, a crisis in the music industry. To really grasp the tech we're about to explore, we have to start with the deeply human problem that took center stage at that 2020 DDX Summit. During one of the producer panels, they asked a question that pretty much perfectly captures the entire industry's frustration. Entering credits in the recording process. Whose job is it anyway? Think about the wild irony there for a second. We literally have the technology to digitally simulate a full symphony orchestra on a laptop in a coffee shop, but we somehow can't figure out whose job it is to type in the drummer's name. A human being still has to sit there and key in creator credit information during a session. Is it the producer's job, the audio engineers, the artists? Because there's no clear, standardized workflow for this, it frequently just doesn't get done. And this missing data creates what they call the metadata miasma. It completely leaves independent and DIY musicians hanging. At the summit, reps from major distribution platforms pointed out that the modern music business absolutely runs on real-time data. But DIY artists or even composers throwing together complex audio-visual productions are pretty much left entirely on their own to input core metadata. So when they inevitably make a mistake or accidentally leave off a collaborator, it directly translates to missing credits and lost payments. The emotional toll here is huge, you guys. People simply are not getting paid for their hard work, and the industry desperately needs a fix. Section 2. Capturing credits at source, the importance of RIA. The absolute consensus at the DDX Summit was crystal clear. If we want to clean up the messy back end of royalty payments, we've got to start at the very beginning of the creative process. That brings us to standards like RIC and RIN, the Recording Information Context and Recording Information Notification. These were heavily promoted by DDX because they are designed to capture metadata right at the source, basically in the studio the exact moment a song is born. The summit showcased a bunch of tools trying to pass this cleanly formatted data to everyone in the value chain. Now, it's a brilliant standard for sure. But here's the catch. Having perfectly formatted data requires a robust, dynamic system to actually receive it. And as we'll see, that RIC and RIN data is the absolute perfect fuel for the database we're about to dive into. Section 3. Kyle Smith's patented solution, SeedTreeDB. Let's look at how this standardized data powers Kyle Smith's groundbreaking approach, which is detailed in U.S. Patent 12,664,142. It's called a hierarchical script database. Let's unpack that definition, because honestly, it is pretty mind-blowing. Think of this database like a highly intelligent organic family tree. In a traditional database setup, nodes or folders basically just sit there, passively holding your information. But in Smith's hierarchical script database, the nodes contain both data properties and function properties, written active script. This is a massive, massive paradigm shift. It means the nodes aren't just dumb storage, they are active scripts capable of independently executing commands right there in an interpreter environment. To put that into perspective, think about legacy databases as passive receptacles for static data. If a song gets played, a person or some piece of external software has to manually log that transaction into the database. But with Smith's invention, we are upgrading to an active, event-driven ecosystem. In this database, the nodes themselves are literally listening for events. When something happens, say a song is streamed, the system grows dynamically and automatically. It essentially builds its own audit trail on the fly. How cool is that? Section 4. An event-driven tree database, how it works. Let's slow down for a second and get into the actual mechanics of how this patented architecture processes an event in real time. Here is where the magic happens. An interface module receives an event, like a notification that a specific song was played. The parent node, which represents that song, receives the event and instantly instantiates a brand new child node to hold the specific data for that single transaction. Then it passes the identifiers of both the child and the parent over to what's called a kernel function. This kernel function's entire job is to add metadata to both, permanently linking them together within the tree data structure. It literally grows a brand new branch to hold the new data and seamlessly links it right back to the parent.
Section 5. Automating royalties and rights. The payoff.
So you were probably wondering, why does this highly specific software architecture matter to that struggling DIY musician we talked about earlier? Well, here is the payoff. Step by step, this completely eliminates the manual accounting that leaves artists unpaid. When an incoming event, like a performance report from Spotify or Apple Music, hits the database, it's processed by the event handler node. That node logs the transaction by creating the child node, but because it has those active function properties we talked about, it can automatically trigger an outgoing payment event. The patent specifically details how it can automatically connect to external financial institutions to debit the distributor and credit the publisher, performer, or writer. And it does all of this without a single human finger ever touching a keyboard.
To give you a concrete example, the patent maps out a very specific scenario. Let's say a reporting entity notifies the database that a song was played exactly 345 times. Instead of someone having to do the math, the nodes autonomously calculate the complex royalty splits based on the embedded licensing contract, and then they route those microtransactions entirely on their own. It is just incredibly efficient. That whole metadata miasma vanishes because the active script handles the routing intrinsically.
Section 6. Exploring all possible paths, the future of music rights. Which brings us to the true scale of what this database can achieve for music rights management, moving way beyond just single songs to managing entire industry catalogs. The inventor has pointed out that, unlike traditional databases, this branching tree structure is explicitly designed to map all possible paths in musical rights management. So it doesn't just log a single play. It can track derivative works, manage risk, handle crazy complex international collection rules, and maintain the hierarchy of sections, terms, and definitions hidden within massive licensing contracts. Everything remains connected, verifiable, and transparently executable. So I'll leave you to chew on this final thought. We just talked about how industry leaders at the DDX Summit are practically begging for a solution to uncredited and unpaid creators. And we've seen how tools like Rick and Rin are ready to standardize the data. If we literally have the patented technology to ensure every single creator is perfectly credited and paid autonomously at the source through an active, event-driven tree, when is the music industry going to finally make the switch and abandon FASF databases forever? It's a billion-dollar question. And the crazy part is, the technology is already here, just waiting to be unleashed.